Example 11.4. In this example, a crane is used to lower weights into the sea for an underwater construction project. We need to determine the tension of the rope for the crane due to a rectangular concrete block when it is suspended in air and also when it's completely immersed in water. To solve this problem, we're going to neglect the buoyancy force due to the air as well as the weight of the rope. If we do the analysis while the concrete block is suspended in air, the only two forces acting on the system is going to be the tension of the rope and the weight of the concrete. So we could say that the tension of the rope is equal to the weight of the concrete. The weight of the concrete is simply going to be the density of the concrete, the volume of the concrete, and the value of the gravity. The density of the concrete is given to be 2,300 kilograms per meter cubed. The volume of the concrete is equal to 0.4 times 0.4 times 3 meters, which is equivalent to 0.48 meter cubed, and gravity is equal to 9.81 meter per second square. Therefore, the tension in the rope is going to be equal to 10.8 kilonewtons. Let's now do the analysis when the concrete block is now submerged into water. In this case, now the forces are going to be the tension in the rope, the weight of the concrete block, and the buoyancy force. Therefore, the tension in the rope is going to be equal to the weight of the block minus the buoyancy force. The weight of the concrete was calculated in the previous step, so let's now calculate the buoyancy force. That is simply going to be the density of salt water, the gravity, and the volume that is submerged, which is exactly the same volume as the concrete block. Therefore, if we substitute, the density of salt water is 1,025 kilograms per meter cubed. Gravity is 1.981 meters per second square. And the volume we calculated in the previous step and is equal to 0.48 meter cubed. Therefore, the buoyancy force is going to be equal to 4.8 kilonewtons. If we calculate the tension in the rope, we use the weight of the concrete, which we calculated in the previous step to be 10.8 kilonewtons, minus the buoyancy force, 4.8 kilonewtons. That gives us a tension that is going to be equal to 6 kilonewtons. If you notice, the fact that you place the concrete block into the water reduces the tension in the rope by about 55%. Please go back and make sure that you understand why we do the procedure differently in air and in water, and make sure that you're able to get the same results.